In this video, we are going to be doing the first set of practice problems for our energy calculations. So on this first sheet, which is the first of several, things to remember. Your mass is always going to be 100 grams for the entire sheet, so the M is always going to be 100. You have to show all work. We're going to put your answers in proper scientific notation. We're going to include the units. I want you to indicate absorbed or released, and you're going to have to label everything. So it sounds like a lot. It's really not that much. So as far as labeling everything, that means on this little heating cooling curve, you're going to label all of it. What is AB? What is this arrow? What is this arrow? All these arrows that I drew in, you would essentially draw them in and label all them. Now for the work. What it's asking, if you look at number 1, it says AB, and then there's an answer here. So what they're really saying is how much energy does it take to go from A to B? Well, if we look at the temperature on the left, it says A is at -9 and B is at 0. So we know that the thing that's happening here is a change in temperature because A to B is a heating up. So here's what it should look like. Number 1, put your line segment, AB. That has to be there so I know which one I'm looking at. And then the next thing would be, well, what's happening? Well, we just said it, temperature change. There's a formula for that. Q equals MC delta T. So then you write out your formula. The M for this is going to be 100 every time it says it in the sheet. You are going to solve for Q, at least on this worksheet. We're going to be solving for Q every single time. The C value for water is going to be 4.18. That's what it is always as far as we're concerned. And the delta T is going to be from -9 to 0. We keep that. It's going to be always positive. We're always just going to make it positive. So in this case, it would be 9 degrees. Okay, so then you do your math, and you're going to get some number. I don't have a calculator with me, but I do have it pre-done. So it's going to look like this. So you'll get 3,762 joules. You are then going to put that in scientific notation, which for this, we can just round it. It would be 3.8. because obviously the 6 rounds the 7 up, so it would be 3,800 or 3,800, 3.8 times 10 to the 3 joules. And because we're going up the curve, it's in the endothermic direction, that would be absorbed. So endothermic is always going to be the absorbed, and exothermic would always be the released. And then you would just take your answer and write it there. And that's all you're going to do. I'm going to do a bunch of these problems with you so that I can show you everything here. So let's look at segment BC. Segment BC, there is no temperature change, so it can't be an MC delta T. So for segment BC, we are going to have to use the formula Q equals MHF, because during BC, that's when fusion or melting happens. So if you know your heating cooling curve, it should make this a lot easier. So there's my Q equals MHF. Next, my M, 100. My Q, it's what I want. The HF for water, we look it up, it's 334. Your formula should look like this. Solve for X, and you get 33,400 joules. Put it in scientific notation, 3.3 times 10 to the 4 joules absorbed. So it's going to look like that. Number 3, what's happening during CD? Well, that is another temperature change because we're on an angle. So my formula, Q equals MC delta T. Again, M is 100, Q is what we want. The C value for water is 4.18. My delta T is much bigger now. My delta T is from 0 to 100, so in this case it's 100. So there's our number, 41,800 joules. Put it in scientific notation and round it. And there we go. So that's number 3. Now let's look at number 4, DE. So on segment DE, we have vaporization. So Q equals MHV, because V is for vaporization, and I know it because I know how to label a heating cooling curve, and that's what's happening. A liquid is turning into a gas. Next, the M for this sheet is going to be 100. The Q is what we want. The HV for water is 2260. we do our math and we get some big number. We get 226,000. So then when you round it and put it in scientific notation, it would be 2.3 times 10 to the 5 joules. Still absorbed because we're still going in the up direction. And then dE or EF, well, that's a temperature change again. So if you notice, the delta T's are always going to be the angled parts, and then the flat parts are either going to be HF or HV. So segment EF, it's an MC delta T. The M is 100, the C is 4.18, like it always is. The Q is what I want. The delta T is a little smaller because E to F is really only 11 degrees because it says it right over here. E is at 100, F is at 11, subtract the 2 and you get 11 degrees. There's your setup, there's your answer. 4.6 times 10 to the 3 joules absorbed. Now, I'm going to do one more with you, but turns out, if you've noticed, that I just did everything on the curve. So everything else that we're going to do is going to be some variation. So let's look at BA. So number 6 wants for BA. But if you think about this, AB and BA are basically the same thing. What's the only difference? Well, in one, the temperature is going up. In the other, the temperature is going down. So it turns out I know the answer. The answer is going to be 3.8 times 10 to the 3 joules. But because I'm going down from B to A instead of up from A to B, it's not going to be absorbed anymore. It's going to be released. So for this one, you do have to show all the work. So Q equals MC delta T, just like number 1. 100 is my M, 4.18 is my water, is because it's water, 9 is my delta T. This number again, rounded, it's going to look like that. The only real difference is going to be this. And that's it. Let's look at a few more. So as you can tell, I'm going to do most of these, probably like half these problems with you, just to give you a general idea of how they work. And obviously I'll give you another one where I won't help you as much because it's all going to be the same thing. So number 7. So 7 is C to B. So if we're doing C to B, well, you guessed it, it's going to be B to C, but instead, so it's going to be this number. So instead of absorbed, it'll be released. So big surprise. Formula, so the line segment, we've got our formula, we plug in our numbers, we solve for our answer, we put it in scientific notation, and now it's going to be released. Okay, so that's pretty easy. When for number 8, it's D to C. I shouldn't need to do that with you. It's the same as number 3, which is C to D. For number 9, it's F to E, which is the same as E to F. Again, I shouldn't need to do that with you. It's the same. It's just going to be reversed. So you should get the idea at this point. Remember, you do have to show all the work. What I do want to get to, though, is some of the combinations. So when we get to the combinations, it's a little bit more involved, but not much more. So for this one, it's A to C. So number 10, it says A to C. So think about what's happening. To go from A to C, you have to really go from A to B, and then you have to go from B to C. So what you're really saying is that segment AC, if I want to calculate that, it's really segment AB plus segment BC. Well, guess what? We already have the answers. Segment AB is this, and segment BC is this. So if I just add those together, I get the answer. You, however, don't get to do that. I want to see all the work just like I'm doing it here. So you're going to have your line segments. You're then going to have your formulas that line up with your line segments. In other words, the energy Q is going to be this plus this. This represents AB's energy. This represents BC's energy. Then you're going to plug in all your numbers just like you've been doing. You already know these numbers. And then you're going to get your answers. Then you're going to add them together. Then you're going to put it in scientific notation. So for 10 AC, it's going to be 3.7 times 10 to the 4 joules, and we're absorbed. Okay, I'm going to do one more with you. I'll set up number 12. 12 is A to F, so if you notice, it's the whole curve. So the reason I specifically did all of these individual answers with you was so that when now you have all the answers for the individual segments, everything else is just some combination of segments, whether it just be flipping the A to R or adding up individual segments, you actually have all the answers to this. So for A to F, it's going to look like this. AB plus BC plus CD plus DE plus EF. Then you're going to plug your formulas in. MC delta T for AB, this one for this one, and you're going to keep these neat. Then you're going to do all your numbers and solve it just like we did here. The last one I'm going to do with you is going to be 15. 15 is an easy one. It's hard to see. I'll show it to you in a second. But 15 is saying A to F to A. So what it's really doing is saying if you did A to F and then subtracted F to A. So we already know the answer. The answer is 0 joules. That should be pretty easy. What you need to do is tell me why it's 0 joules. So, or prove that it's 0 joules. So your answer is going to start to look like this. So you're going to have F to A, which is this whole section. We know the answer already. You've got to prove it. So then you'll have your formulas under each one of these, just like we did in number 12. Then you're going to have F to A, the reverse, which is going to look like this, and then you'll have your formulas underneath, and then your numbers plugged in, and then your math, and then you're going to have some big number minus the same big number. The whole thing equals 0. That's the last problem. All right, so your job is to show it to me and prove it to me mathematically. We already know the answer. The amount of energy it takes, if I absorb all this energy to go from F to A, and then I release it all to go back to from A to F or reversed, it's going to be 0. It's like if you go to the store and you buy a bunch of items and then you go back the next day and decide you don't want to keep them and then you return them, the total amount of money change in your bank account once it all clears would be 0 because you bought an item for, let's say, $100 and then you went to the store and returned that item, so your bank statement in the end wouldn't change. It would be plus 100 minus 100 and they cancel each other out. That's what this is effectively doing, but you need to show it to me. The last question at the bottom is, why does DE take more time than BC? So if you notice, DE is longer than BC, and they're saying, why does it take more time to essentially boil water than it does to melt water? I will give you a hint. It has to do with the value of the specific heat and the the value of the heat of vaporization and the value of the heat of fusion. And if you compare those numbers, you should get an answer. The trick is to think about the units and the definition. If you read the definition and understand that the numbers are different, it should give you a pretty easy answer for that question. And that includes the work for this video.